when you look at a unit circle at the coordinate of each of those angles, and you can keep that out because we're going to use the unit circle today. The coordinate of the angle on that unit circle, the first coordinate is the cosine of the angle. So for example, if you type cosine 60 into your calculator, you will get 0.5. And if you look at your unit circle, and if you look at the x-coordinate of 60, you will see that it's 1/2. Okay? So the unit circle actually gives you trigonometric values that are accurate. The cosine is the x-coordinate, and the sine is the y-coordinate. Okay? Looking to see if I had that on the wall somewhere. I don't think I did. Cheesy smile. Cosine, sine. That's what that is. Cosine is the x-coordinate. Sine is the y-coordinate. That's what that means. Tangent is the sine divided by the cosine. That's what TSC means over here on the wall. Tangent is sine divided by cosine. So we can find all three of the basic trigonometric functions by just looking at the unit circle, and tangent would be dividing two of them. And then we can find the secondary trigonometric functions just by flipping the original three like we learned the other day. Okay, and our job today is to just use the unit circle angles to come up with some of these values. So, the cosine of 30 degrees is, we're not using a calculator, you really don't need it today. Can anybody tell me, Tanner? It's root 3 over 2. Everybody see the cosine of 30 is root 3 over 2. Okay. Sine of pi over 4 would be, Dayton? Root 2 over 2. So we're just doing this today, but it's going to get more difficult. I mean, how challenging can I make you finding trig functions on the unit circle? That's what we're going to see. That's the challenge. Cosine 5 pi over 6. Anybody see where that is? Cosine 5 pi over 6, sir? Negative root 3 over 2. Very good. So those are the baby problems, just to get us warmed up. Does anybody not understand where we're getting those answers? Tangent of 135 degrees. Tangent, by definition, is sine over cosine. Remember, we're not using calculators today. We're using the unit circle. So tangent, by definition, is sine over cosine, TSC. The sine of 135 degrees is root 2 over 2. The cosine of 135 degrees is root 2 over 2, negative root 2 over 2. And anytime you divide something by itself, it's 1. And since one of those is negative, the answer is negative 1. Is the tangent always 1? No. It just works out well on those 45s. 45, 135, 225, where the two numbers are basically the same. All right. secant pi over 6. Well, we have to know what a secant is. The secant is the flip of the cosine. So first we have to find the cosine of pi over 6, and then we have to flip it. See how this gets just a little more difficult? But since we're going slow and methodically, we should be able to handle the increase in difficulty. So it's the flip of the cosine. The cosine of pi over 6 should be root 3 over 2. Looking at your unit circle, see it? Root 3 over 2. So we flip it and get 2 over root 3. Can't have a root on the bottom. So now we have to multiply the top and bottom by root 3. And we get 2 root 3 over 3. I love this stuff. It is. Okay, let's try a negative angle. Cosecant of negative pi over 6. Now, negative pi over 6 means I'm going against the grain a distance of pi over 6. So, if I go against the grain a distance of pi over 6, where do I stop? On what dot? No. Tanner?
Is it 11 pi over 6?
Yes. I stop at 11 pi over 6. Look at your unit circle. I'm starting at 0. Pi over 6 is 30 degrees. But I'm not going 30 degrees. I'm going negative 30. So I'm going to go the wrong way. Basically, 1 dot. Because on your unit circle, 30 degrees is 1 dot from 0. So I'm going to go the wrong direction 1 dot. And that's going to put me at 330. So negative pi over 6 is coterminal, word we learned yesterday, to 330. So you can say that negative pi over 6, we could just use 330 as our angle. Instead of using negative pi over 6, you can treat it as 11 pi over 6. Because they have the same cosines and sines because they land on the same dot. So you can turn it into whatever dot it actually lands on. So the sine of negative pi over 6 is equal to the sine of 11 pi over 6. Because that's where they both stop. The sine of 11 pi over 6 is negative 1/2. And if you flip that, you get negative 2. Okay, so there's a lot there. That was a flip function with a negative angle against the grain angle that landed on 11 pi over 6. You try this one. I want you to find the cotangent of 210. Cotangent of 210 is the flip of the tangent of 210. The tangent of 210 is sine over cosine. So if I flip sine over cosine, that's cosine over sine. So cotangent is cosine over sine. Instead of saying 1 over the sine over the cosine and creating this massive compound fraction, the flip of sine over cosine is just cosine over sine. So the cosine of 210 is negative root 3 over 2. The sine of 210 is negative 1/2. The 2's cancel and the negatives cancel. My answer should be root 3. Secant of 210 is 1 over the cosine of 210. And the cosine of 210 on your unit circle is negative root 3 over 2. Flip it, it becomes, well, we already did this problem up there. Negative 2 root 3 over 3. You could flip it, multiply top and bottom of root 3. I already had this work 2 problems up there. So I just wrote down the answer that I would have got up there. But you would flip it, multiply top and bottom by root 3, and write your answer.